Hello, business stats folks. Let's talk about some basic probability theory. Let's say we have a setup like this. You are playing Monopoly. You have 6 hotels on this one stretch here. So 1, 2, 3, 4, 5, 6 hotels. And all 3 of the people you're playing against are sitting right here in visiting jail, which means on their next roll, they're pretty likely that any of them might hit your property and give you a bunch of money. We want to know exactly what that probability looks like, and then we'll talk about how it changes after each roll. Okay, so let's walk through that here today. So we're going to treat this like a binomial. We're going to say they either hit a property or they don't hit a property. So to do that probability, we have to set up what is the probability of a sum of 2 dice. And that looks like this. Okay, so if I hold that back. So you can roll a 2 only one way, a 1 and a 1. You can roll a 3 two ways, a 1 and a 2, or a 2 and a 1, and so on and so forth. So 3 for 4, 5 for, and there's 36 total possibilities. So 7 is the most likely with 6 ways you can roll it. Then 8 and 6 each have 5, etc. going down. And if we look at what they have to roll, they need to roll either a 1, a 3, a 4, a 6, a 8, or a 9. So if we look at the probability of them hitting one of your properties, it looks like this. They won't roll a 1, but they 2 out of 36 times will roll a 3, 3 out of 36, 5 out of 36, 5 out of 36, and 4 out of 36. You sum those up. 2 plus 3 is 5, plus 5 is 10, plus 5 is 15, plus 4 is 19 out of 36. So 52.8% of the time, someone will roll something that ends up hitting your property. Which also means that 1 minus 52.8%, you see that? The probability of them missing your property is 1 minus that, which means 47.2% of the time they will miss your property. So if we want to know, hello cat, the probability that all 3 will miss, it looks like this. Assuming each roll is not correlated to the other, generally rolls of dice are independent, then we look like this. So we'd have to miss, 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 right? So if you take 0.472 times 0.472 times 0.472, you get 10.5%. So only 10.5% of the time will all 3 of your friends miss your property, okay? But let's say the first guy rolls and gets a 10. Okay, so the dog gets a 10. He's going to go chugging up to free parking, and now you only have 2 more chances. That changes our probabilities. So now if we look here, now all it's going to take is 2 misses for you to get nothing. And the probability of 2 misses is 0.472 squared. So now it's 22.3% of the time that you won't have anybody hit your property. So the probability condition on the first one missing your property went from 10.5% to 22.3%. So there's almost twice, a little over twice, the probability there was that you will now have nobody hit your properties. And that's, the difference between joint and conditional probabilities. The first one was a joint. All 3 things happening. Now it's conditioned on the first one not happening, basically. Okay? And then, of course, on the third, if the second guy misses, okay, so if the second guy also rolls a 10, okay, and then we only have 1 more shot, then we're back to here, where now, the one roll, 52.8% of the time they'll roll something we want, and 47.2% of the time they'll roll something we don't want. So now the conditional probability of them all 3 missing your properties has gone way up. And so I'm having a hard time focusing on that. I'm sorry. All right? So that's the idea. That's how the joint and conditional probabilities break down in a situation like this. So that's one example. Now I'm going to go play around with Hearthstone a little bit, and we'll put up a second example of the same exact thing happening. And if they all 3 miss, and you're set up like this, if you're low on cash, and you happen to be staring down Park Place and Boardwalk hotels, this could be a life or death situation. So you got to know your probabilities. I'll see you on the Hearthstone video.